For the following telescoping series, find a formula for the nth term of the sequence of partial sums S sub n. Then evaluate the limit as n approaches infinity of S sub n to obtain the value of the series or state that the series diverges. And we're given this series that goes from k equals 1 to infinity, 1 over the square root of k plus 6 minus 1 over the square root of k plus 8. And we're told that this is telescoping. And what telescoping means is that if you write out enough terms, they're going to start canceling as you move out. The inner terms are going to cancel, and you're going to be left with a finite number of terms instead of an infinite amount of terms once the cancellation is done. So let's start writing out a few of these terms and see what happens. So we'll call this S sub n. If we plug in a 1 here, this would give in the denominator a square root of 7, and then this would give a square root of 9. So 1 over square root of 7 minus 1 over square root of 9. Okay, now this is a sum, so plus, and now we'll plug in a 2. This would be 8 and 10 on that one. So 1 over square root of 8 minus 1 over square root of 10. And then the next one, you can see the pattern, 1 over the square root of 9 minus 1 over square root of 11, 1 over square root of 10 minus 1 over square root of 12. And you could keep going on that if you wanted, to a dot, 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 and then go towards the last terms. So let's say that we plug in a n minus 2, because this is a series, a partial sum series. So let's plug in an n minus 2, because we're going to go out to n. So the third to last term on n minus 2, if we plug in an n minus 2 here, it would end up being n plus 4. And an n minus 2 here would give us n plus 6. Okay, so we'll say 1 over the square root of n plus 4 minus 1 over the square root of n plus 6. The next term would be 1 over the square root of, well, it's 1 more than the last term, so n plus 5 minus 1 over the square root of n plus 7. And then our last one, when we plug in an n here, would be 1 over the square root of n plus 6 minus 1 over the square root of n plus 8. Okay, so it's a partial series that goes to n. And now we can look at some of these middle terms and see what they're doing. So does anything happen when we look at these terms and in terms of cancellation? So we have a negative 1 over the square root of 9 here. And we have a positive 1 over the square root of 9 here. So those are going to end up canceling out. Okay. We've got a negative 1 over square root of 10 here, and we've got a positive 1 over square root of 10 here. So those two cancel out. Okay, and then we've got negative 1 over square root of 11. And if we wrote one more parentheses here, right here, the next one would be a positive 1 over square root of 11. So that one cancels with one that's going to be written here that we haven't written. So every one of these terms is going to get canceled, starting with this one and on out how far? Well, let's start from the end and see what cancels. So we've got a positive 1 over square root of n plus 6 and a negative 1 over square root of n plus 6. Okay, so that one and that one cancel, and they would, let's see, we would have a 5, we would have a negative square root of n plus 5 would be right here had we wrote the previous parentheses right here. Okay, so that one's going to cancel. So all of these are going to cancel with terms that came before them, whether they're positive or negative. They're all going to cancel. So the only ones that are going to be left at the end of this thing, this one cancels too. So all these inner terms are cancel, 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 cancel. But we are left with a couple terms at the beginning, and we're left with a couple terms at the end that have nothing to cancel with. And that's because we stopped at n. Okay, so once we do all that cancellation, S sub n is equal to 1 over the square root of 7 minus 1 over, no, plus 1 over the square root of 8. And then these are both negative here, so I'll just put a negative and then make them positive on the inside. n square root of n plus 7 plus 1 over the square root of n plus 8. Okay, they're both negative. I'll put the negative out front. Okay, so we've got our partial series here. Okay, so now we need to send this thing to infinity to see what the actual sum is and see that if it has a value or if it diverges to infinity. So the limit as as n approaches infinity of s of n is equal to the limit as n approaches infinity of 1 over square root of 7 plus 1 over square root of 8 plus, or minus actually, keep those in parentheses, 1 over square root of n plus 7 plus 1 over the square root of n plus 8. Okay, now for sending that to infinity, no variable, nothing happens. These two do have a variable, so as we send these two variables to infinity, the denominators of both of these go to infinity, which means that the fractions themselves both head to 0. Okay, so this limit is equal to 1 over the square root of 7 plus 1 over the square root of 8, which means this converges, and that is what it converges to.